Now that we understand the various kinds of interactions that covalent compounds can exhibit between one another, we are ready to see how these interactions dictate some of the properties of liquids. Think about a few different kinds of liquids and what happens as they move. Think about pouring a glass of water. Now think about pouring maple syrup. There is a distinct difference in the ability of these liquids to flow. The ability of a liquid to resist flow is called viscosity. Water has a low viscosity because it flows freely, while syrup, honey, and motor oil have a high viscosity because they flow quite slowly. We measure viscosity quantitatively by measuring the rate at which a metal ball falls through a substance. The slower it falls, the more viscous the liquid. There are a number of factors that dictate the viscosity of a liquid. First, the intermolecular forces, or IMFs, between the molecules. The more strongly the molecules attract one another, or stick together, the stickier and more viscous the liquid will be. The size and shape of the molecules also play a part. Very tiny molecules will be less viscous because of enhanced mobility. Very large molecules will have a more difficult time moving past one another, which will restrict flow and cause a greater viscosity. Then there is temperature. Higher temperatures mean more kinetic energy, which causes the intermolecular forces to dissipate and thus a reduced viscosity. Here is a chart of some various molecules and their viscosities. We can see that water is very low despite the strong hydrogen bonding because water molecules are so small, whereas more complicated substances like honey will have much larger viscosities. And that's how things on the microscopic scale can dictate how a liquid behaves on the macroscopic scale.